Namaskar, I am Dan Gaude, Assistant Professor in Mathematics, Center for Distance Education, Shivaji University, Kolhapur. Today I will discuss Series theorem from group theory of Algebra MSc first semester post. Statement of Series theorem. Two subnormal series of a group G have isomorphic refinement. Let G be a group and let singleton E is equal to H naught subgroup of H1 subgroup of H2 dot let subgroup of Hn is equal to G and singleton E is equal to K naught subgroup of K1 subgroup of K2 dot subgroup of Km is equal to G with two subnormal series of G. Define Hij is equal to Hi dot Hi plus 1 intersection Kj as Hi normal in Hi plus 1 we get Hi dot Hi plus 1 intersection Kj is a subgroup of G for each I and for each J. Now Hi is normal in Hi plus 1 and Kj is normal in Kj plus 1. Then by Sullivan's lemma, Hi dot Hi plus 1 intersection Kj is normal in Hi dot Hi plus 1 intersection Kj plus 1. Therefore Hij normal subgroup of Hij plus 1. Now Hi0 is equal to Hi in dot Hi plus 1 intersection K0 is equal to Hi dot Hi plus 1 intersection singleton E. Hi dot singleton E is equal to Hi. Now Hi dot Hi plus 1 intersection Km is equal to Hi dot Hi plus 1 intersection G. Hi dot Hi plus 1 is equal to Hi plus 1. For Hi is subset of Hi plus 1. From 1, 2 and 3 we get a chain containing n plus 1 elements not necessarily distinct, which is as follows. Singleton E is equal to H naught is equal to H naught naught is not a subgroup of H01 is subgroup of dot H0m is equal to H10 is equal to H1 and so on is equal to Hn is equal to G. This chain defines the chain in one. The set of factor groups of the chain represented in 3. Hij plus 1 divided by Hij so that 1 less equal I less equal Jn, 1 less equal J less equal Jm minus 1. Similarly, by defining Kji is equal to Kj into Kj plus 1 intersection Hi, we obtain a subnormal chain containing an m plus 1 element as follows. Singleton E is equal to K0 is equal to K00 is subgroup of K01 is subgroup of is subgroup of K0n is equal to k1 0 is equal to k1 is subgroup of k11 is subgroup of dot 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 is equal to k20 is equal to k2. Note that the two chains represented in 4 and 5 not necessarily contain distinct groups. The chain 5 represents the chain 2. The set of factor groups of the chain represented in 5 is kji plus 1 divided by kji such that 0 less equal j less equal m 0 less equal I less equal n minus 1 as hi normal in hi plus 1 and kj normal in kj plus 1 by Jason's lemma hi dot hi plus 1 intersection kj plus 1 divided by hi dot hi plus 1 intersection kj is isomorphic to kj dot kj plus 1 intersection hi plus 1 divided by kj dot kj plus 1 intersection hi, and therefore hij plus 1 divides hij is isomorphic to kji plus 1 divided by kji. This isomorphism establishes one-to-one on-to correspondence between the two sets represented in 4 and 6, deleting the repeated groups from the chain represented in 3 and 5. We get the subnormal series of distinct groups that are isomorphic refinement of the subnormal series represented in 1 and 2 given by respectively. Example, give the isomorphic refinement of the two subnormal series of Z plus singleton 0 is normal, 60Z is normal, 20Z is normal Z, and singleton 0 is normal, 245Z is normal, 49Z is normal Z. Define H0 is equal to singleton 0, H1 is equal to 64Z, H2 is equal to 20Z, S3 is equal to Z. K0 is equal to singleton 0, K1 is equal to 245Z, K2 is equal to 49Z, K3 is equal to Z. Define Hij is equal to Hi dot Hi plus 1 intersection Kj for all 0 less equal I less equal to 0 less equal j less equal 3. Therefore H0 0 is equal to H0 is equal to singleton 0, H01 is equal to H0 dot H1 intersection K1, H1 intersection K1 is equal to 64 60Z intersection 245Z. Therefore LCM of 60 to 45 is equal to 2940 Z. H0 is equal to H0 dot H1 intersection K2 is equal to H1 intersection K2 64 Z intersection 49 Z is equal to 2940 Z. H0 60 Z and so on. Hence, the repairment of the series represented in 1 is singleton 0 H00 is normal, subgroup of H01 is subgroup of H02 is subgroup of H03 is equal to H1 is equal to H10, and so that singleton 0 is a subgroup of 2940Z is subgroup of 2940Z is subgroup of 60Z is subgroup of 60Z is subgroup of 20Z is subgroup of 5Z is subgroup of Z. Deleting the repeated factors, we get singleton 0 is normal in 2940Z is normal in 60Z is normal in 20Z is normal in 5Z is normal in Z. This is refinement of the series. Singleton 0 is normal in 60Z is normal in 60Z is normal in 20Z is normal in Z. Similarly, deleting Kij is equal to Kj dot Kj plus 1 intersection Hi, we can obtain the repairment of the series. Singleton 0 is equal to K naught is normal in K1 is normal in K2 is normal in K3 is equal to Z, and which is as follows. Singleton 0 is normal in 2940Z is normal in 980Z is normal in 245Z is normal in 49Z is normal in Z. Next definition, on the subnormal series Hi is equal to H0, H1, H2 dot Hn of a group G is a composition series if all the factors groups Hi plus 1 divides Hi are simple. H0 is equal to singleton and Hn is equal to G.